Hello, welcome again. We are solving some questions of theory of machine. The topic is gear train. Question number 58 from gear 2017 ME-01 is in an EP cyclic gear train shown in the figure. The outer ring is fixed when the sun gear rotates counterclockwise at 100 rpm. Let the number of teeth on sun, planet, and outer gears to be 50, 25, and 100 respectively. The ratio of magnitude of angular velocity of the planet gear to the angular velocity of carrier arm is dash. So this is your planet gear, this is your sun gear, this is your carrier arm, and this is your outer ring gear. Okay, so given that the RPM of sun gear is your 100 RPM, and that is in counterclockwise direction. In this direction. So taking counterclockwise is negative. Okay, and outer ring is fixed, so its RPM is 0, so NR is 0. So number of teeth on sun gear are given as 50 and position TS, and number of teeth on planet gears are given as 25, and number of teeth on ring gear is 100. Okay, now preparing first of all table and then applying the condition of sun gear RPM as 100 RPM counterclockwise and ring gear as fixed. Okay. So now first of all, assuming that the this arm is fixed or carrier is fixed and sun gear is given 1 revolution. So for 1 revolution of sun gear, the revolutions of planet gear will be TS by TP, because their velocity ratio will be in the ratio of their teeth, and the velocity of P will be in opposite direction as compared to sun gear, because they are in external mesh, so there will be minus sign, and NP by NS will be equal to minus TS by TP. Okay, so as NS is 1, so NP will be equal to minus TS by TP. Okay, so the angular velocity of planet gear is your minus TS by, for 1 revolution of sun gear, the planet gear will revolve minus TS by TP. And now this planet gear is in external mesh with the ring gear, so and the revolution of planet gear is minus TS by TP, and the ratio of RPM of ring gear and planet gear in the ratio of will be in the ratio of number of teeth on planet at sun gear. So as this TP by TR will be your NR by NP, and NP is your this quantity. So here it will be minus TS by TP into TP by TR will be your revolution of ring gear. Okay, so TP will cancel out, so here it will be minus TS by TR. Okay. So this is the first row of the table. When the arm is fixed, the sun gear is given 1 revolution, and so for sun gear to be given as 1 revolution, the revolutions of planet gear will be minus TS by TP, and revolutions of ring gear will also will be here minus TS by TR, and minus sign will be there for planet gear as well as for ring gear, because in external mesh the sign changes, and in internal mesh the sign doesn't change. Okay. So when X revolution is given to sun gear, previously 1 revolution was given, now X revolution was given, then it will be minus X TS by TP for planet, and for ring gear it will be minus TS by TR. Okay, minus TS by TR. Okay. Similarly, now up till now the arm was fixed. Now arm is also given by revolution. So then the revolutions of different gears will be, revolution of arm is Y, and revolution of sun gear is X plus Y, and revolution of planet gear is Y minus X TS by TP, and revolution of ring gear is Y minus X TS by TR. Okay. So now according to given condition, the outer ring gear is fixed. Okay, so outer ring gear revolutions are Y minus X TS by TR. so this is 0. Okay, so TS is your 50, TS is 50 and TR is 100. Okay, so it will be y minus x by 2 is equal to 0, equation number 1. Okay, and now sun gear is rotating in counterclockwise direction at 100 rpm. So as it is in counterclockwise direction and taking counterclockwise direction as negative quantity, so we can put the sun gear revolutions as minus 100. So the sun gear revolution according to the equation is your x plus y. So x plus y is equal to minus 100. So this is equal to so this is equation number 2 and this is equation number 1. Solving these two, we can find out x comes out as minus 200 by 3 revolution per minute, and y comes out as minus 100 by 3 revolution per minute. Okay. So now we have to find out the ratio of magnitude of angular velocity of planet gear to angular velocity of carrier arm. Planet gear is revolution are y minus x ts by t. Now we know the value of y, we know the value of x, we know ts, we know tp. So planet gear revolutions can be, or revolution per minute can be found out. Okay. So y, putting y as minus 100 by 3 and putting x as minus 200 by 3. So this will be plus. So we get planet revolution per minute is as 100 revolution per minute, and arm angular velocity is your minus 100 by 3, because arm revolution is only y. Okay, so as y is your minus 100 by 3, so it is minus 100 by 3. So the ratio of magnitude of angular velocity of planet gear to angular velocity of carrier arm is planet gear for planet gear it is 100 rpm, and for planet angular velocity this is minus 100 by 3. So answer is your 3. Okay, so we have to find out just ratio, so answer is your 3.